Hey guys, welcome back. I'm so glad that you're joining me today. Today we're going to continue to review potential and kinetic energy. Please make sure that you have your guided notes so that you can follow along, and remember to pause or go back and rewatch the video as needed, okay? So what we're going to be able to do at the end of this lesson is you will be able to compare and contrast potential and kinetic energy. I'm going to go ahead and turn my highlighter on. Alright, so we're going to review a little bit of the previous concepts, vocabulary terms that we went over in the previous video. So energy is the ability of a system to do work. The law of conservation of energy states that energy cannot be created nor destroyed. It can only be changed. So it can be changed from one form to another. We can go from potential to kinetic energy. We can go from radiant energy to chemical energy. We can go from chemical to mechanical. Okay, we can go from chemical to thermal energy, but we cannot destroy energy. Potential energy is energy that is stored in an object or a system. So yesterday, the example that I gave you guys was the picture of the girl that was running. Her whole body together works as a system, and it requires energy for her body to move. Okay, that's her body doing work. She has to use energy in order to do that work. And then kinetic energy is energy of motion. And again, you guys know mechanical energy as being energy of movement. So anytime that we have movement involved, something's in motion, then we know that there's going to be mechanical energy involved as well. So there's going to be several different forms of potential energy. We have gravitational potential energy, electrical potential energy, mechanical potential energy, chemical potential energy, and nuclear potential energy. So let's first talk about gravitational potential. So this is going to basically just be any kind of heights that's going to be involved with your potential energy. Yesterday on the previous video, I gave you guys an example of a large rock or boulder that was on top of a cliff. So that cliff was, say, I don't know, 200 meters high, okay? So the higher that cliff is, the more potential energy that boulder will possess. So if I have a cliff that is 200 meters high, and then I have a cliff that is 1,000 meters high, then which boulder do you think is going to possess the most energy? The one on top of the 200-meter cliff or the boulder on top of the 1,000-meter cliff? Well, of course, 1,000 meters is taller than 200 meters, so it's going to be the boulder on top of the 1,000-meter cliff. Okay, so the higher we go, the more height we have, then the more potential energy we have as well. Okay, mechanical potential energy we can see, also known as elastic potential energy. Whenever we take a rubber band and we stretch it out, that is going to be mechanical energy. That rubber band, it did have a starting position here, and then we moved it out, and it was now mechanical energy. It moved. So that is mechanical energy. Potential energy, which we know is stored energy. We're going to call that mechanical potential energy or elastic potential energy. And then we have chemical potential energy. So the example that they've given you guys here is like a gasoline pump. So there are chemicals inside of that gasoline, and those chemicals do possess potential energy, because at the moment they're just sitting inside of this tank. They're not doing anything. That gas isn't moving, it's not flowing, it's full of chemicals, and those chemicals are just waiting to be released to use their energy. And then the same with nuclear and electrical potential energy. So nuclear potential energy, again, we have something that is dangerous, that is a nuclear hazard. It could be something like uranium. Uranium has a bunch of different types of like atoms and things inside of it that will possess that potential energy. And then the same with our electrical potential energy. Okay, so it's the atoms and the electrons inside of those that do possess the electrical and the nuclear potential energy. So there are also several different forms of kinetic energy. We have radiant, which we know to be light energy. We also have mechanical energy, which is energy of movement. And then we have sound energy. You guys all should be pretty familiar with these different forms of energies. We have studied those this year. And then again, we have electrical and thermal energies. So these can also possess kinetic energy. We can hear sound. Sound does travel through waves, and it's moving. Those waves are the sound is traveling through these waves. So that could be sound kinetic energy. Or radiant energy. We can see the light. We know that light also travels as well. So radiant kinetic energy, we have electrical kinetic, and then thermal kinetic as well. We know that there are atoms that are going to move around in here. Once those atoms begin to move, then we know that once those atoms are moving within our thermal energy, that's what's going to generate the heat. Okay, so that's going to be our thermal kinetic, and then electrical, when our electrons begin moving and flowing, they're moving. So again, electrical kinetic. Whoops. Okay, so let's follow this hyperlink. Okay, so what we have here is an example of a roller coaster. There's a cart here at the beginning, and there's a pie chart right here. And as this roller coaster, the cart's moving across this roller coaster, we're going to be able to see how the potential and the kinetic energy are transformed back and forth, just depending on the different positions of the cart. So I'm going to just play it for you one time so you can get the general idea of the roller coaster, and then we're going to walk through this and talk about it together. Okay, so I'm going to go ahead and replay it, and, well, we'll let it go one more time. Okay, so as we can see here, the roller coaster is approaching that very first hill. Whoops. Okay. It was approaching that very first hill, and hopefully you guys were able to see the pie chart that was completely full of potential energy. So at the top of this first hill, the potential energy was the greatest. But look at it now. Now that the cart is at the bottom of the hill, what has happened to the potential energy? That potential energy has been transformed to kinetic energy. You can see your pie chart is mostly blue. There's just a small sliver of potential energy that's left, and it's because that cart is now in motion. All of our potential energy has been transformed to kinetic energy, and we know kinetic energy is whenever an object is in motion. So this cart is moving. It is in motion. Therefore, it possesses most kinetic energy. Oh, there we go. So right here at this top of this turn right here in this loop, we can see now again that the cart's at the top. Again, we're back to potential energy, and we have less kinetic. So let's look and see what happens whenever the cart's coming out of this turn. Okay, so now it come out of the turn. Now it's at this position 5. It come out of that turn, and it is completely, all of the potential energy has now completely been transformed back to kinetic energy. So hopefully you guys are able to see the connection that whenever I have the most potential energy is whenever we have the least kinetic. And whenever I have the most kinetic, we have the least potential energy. So I can't ever have full amounts of potential, and I can't have full amounts of kinetic at the same time. My cart cannot be completely motionless and in motion at the same time. It's just one or the other. Let's look at, well, let's try that again. Okay, so right here, it's all potential energy. Okay, no kinetic. And then coming down the ramp and coming into this first turn, that cart was in full motion. So again, we were mostly back to our kinetic energy. We had just a small amount of potential energy that was left at that moment. So how do you guys think height is going to affect this potential energy? Do you think that if we were to increase the amount, increase the height of this first hill right here, this first incline, then do you think that that's going to increase or decrease the amount of potential energy? So remember, potential energy is energy that is stored energy. So if we were to increase the height of that first incline, let's say up here, and that cart was all the way at the top, then do you think that it's going to have more or less potential energy? And hopefully you guys said more potential energy. So that's our gravitational potential energy. We increase the height, then we're going to increase our potential energy. Okay? So what about mass? Do you guys think that mass is going to have an effect on kinetic energy? If we were to take this cart and we added more people to this cart, then do you think that that's going to increase or decrease our kinetic energy? Hopefully you guys said that that's going to increase our kinetic energy. So as this car rolls up this roller coaster, and if the mass was, say, just doubled, and once that car is coming down this second hill, or I'm sorry, coming out of that first hill, then our kinetic energy is going to be increased. If we were to increase or double the mass of the cart, then it's going to essentially double the amount of kinetic energy that that cart now possesses. Let's go through this one more time. So look at how this potential and kinetic energy is interchanging, guys. It's being transformed back and forth, okay? We can't create energy, we can't destroy that energy. All we can do is transform it back and forth. I'm going to get us back to our PowerPoint again. Let's go ahead and review. Whoops. Let's go to the next slide. Next one. Let's go ahead and review what we have just gone over in this video. So we know that potential energy is stored energy. The greater the height, the more potential energy an object has. So the higher we place an object, the more potential energy it has. That's more energy that's just waiting to be released. Kinetic energy is energy of motion. We know motion is when something is moving. If something's moving, then we're going to always relate that back to our mechanical energy. It's energy of movement, energy that's moving. So we know kinetic energy is energy of motion when something is moving. We know the more mass that an object has, the more kinetic energy it has. The more speed an object has, the more kinetic energy it has. We also learned that there are several forms of potential and kinetic energy, and to restate our law of conservation of energy, we know that energy cannot be created or destroyed. It only changes forms, okay? Let's go to our last slide here. So I would like to leave you guys all with a challenge, okay? So I want to challenge you to create your own roller coaster at home with supplies found at your home. No need to run out and buy anything for this. Just look around your house and see what kind of recyclable materials you can find. You can use pipe cleaners, maybe construction paper if you have glue at home. Even the little brown paper towel or toilet paper rolls. I'm sure we have plenty of those laying around right now. And just construct your own roller coaster. I would ask you guys, or challenge you guys rather, to send a marble through your roller coaster and identify the different changes in the potential and the kinetic energy. See how the energy is transformed from potential to kinetic. And then explore with the height and the mass and see what effect height and mass have on the potential and kinetic energy. If you were to raise the height of your roller coaster, then see how that's going to change your potential energy. If you add more mass to your roller coaster, then see how that's going to affect your kinetic energy, okay? I hope you guys enjoyed this video. I hope to see you guys all soon in class again. Keep yourselves safe out there. Bye.